Do you seek knowledge of time travel? Awaiting instructions. Your warriors have engaged the enemy. Confirmed. I love the smell of napalm. All for the Empire. Doomed to all who threaten the homeworld.
Sorry, Jeff.
Nuclear missile ready.
Nuclear launch detected. Is something burning? That's what I thought. Unauthorized transmission. Incorrect protocol. Drop your weapon. You have 15 seconds to comply. 5, 4, 3, 2, 1. Have engaged the enemy.
Base is under.
I gotcha.
For vengeance.
This is not Warcraft in space. It's much more sophisticated. I know it's not 3D. Stop poking me. What do I look like? An orc?
I don't have time for games, of course. Upgrade complete. Carrier has arrived. 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 Your command: destroy. Affirmative.
All right. Hello to whoever's here. All right. So what we're going to do today is basically we're going to make some CLI tools. I say tools, but today probably will be singular. For now, the only real plan is to go over how to use the Odin's own parsing facilities to parse Odin code and spit out some stuff based on that. So what we're going to do first is just a tool called lookup that allows you to, let's say, give the path of a package or maybe a package name. I haven't decided on that yet. We'll see sort of how that turns out. And it can spit out the function signatures, possibly documentation, and so on for whatever is in that package. So I am doing this way now because it is a good sort of introductory tool for just, hey, I want to parse some Odin code and I want to do something based on the results. So we're going to go over basically, you know, what can we gain from the parsing information? What decisions can we make based on that? And, you know, how does that work? That kind of loop, sort of. So that's the plan. More than anything, though, this is my first this is my first stream back after quite some time. So be gentle. No, but you know, it's also, you know, about hanging out a little bit, right? So, you know, I think that's a little bit what's going to go on as well. We're not going to go hardcore here. We're not going to try to, this is not some kind of speed run or whatever either. And if there are questions about anything, just ask. Also, if you notice anything with regards to the like quality, text size and stuff like that, feel free to speak up, you know, so I can fix it. You know, again, I haven't streamed in a long time. I don't remember my settings and everything, right? So just as a, you know, let me know kind of thing. All right. So again, the plan is to make this tool. What do we have here? We have some blah, 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 and some blah, blah, blah. We have a task build probably we can run here. Let's see. I set this up a little bit earlier today just to have it so I don't have to worry about it now. Yeah, so we have this lookup file. This is buildable already, presumably. So I run the build, we get a binary that does nothing. We can generate tags. There you go. Okay, so we are going to be parsing some Odin. And, you know, for that, we can actually take a look at this website here. I'm gonna make this a little bit larger. This is package.odinlang.org. Mind you, this is on the latest version, so you're not always gonna be up to date here, right? But if we want to parse JSON, we can actually search for Odin parser here and so on. And here we can, for example, parse package is a function that exists here, right? So parse package, we can also parse package from path, which is likely what we're going to do. So this one. And this will essentially just allow you to consume a package and it will output this package type here, right? And so this is going to have files inside of it. And if we go to that, we can actually see that a file has references to statements and imports and so on. Also package declarations, which is actually what we want to look at for the most part. But, you know, this is semi-deep into this. We're just going to take it slow. You know, let me pull up the chat again. Hello, people. So we are going to Odin parser. There you go. And here we could call this Odin parser like this. If you're ever wondering about how to import with a new name in Odin, you can just do this. Put the name before. This allows us to call Odin parser functions. Odin parser like this, right? And now we can do parse package from path, for example, right? So I think that this is what we're gonna do. I do prefer, whenever you see a really anonymous name like this, it can be a good idea to just give it some more specific name. What is this? It's an Odin parser. It's not just parser, right? But at the same time, you know, don't over focus on stuff like this. That it's a little bit pointless. Some, hello, the sound level is good, but some what is this word? I'm not understanding 100% here. Desser on top. What's that mean? Ridge. Oh, okay. DS. Okay. How the fuck do I enable this? Does anyone have any idea? You're 100% right that there's probably a little bit. The peaks are probably a little bit high. I could lower the volume, of course. Let's try some lowered volume on this and see. You know, can we reach a level that's. Is this better? Because now I'm yeah, I use OBS, yes. I am not a streaming expert. So all advice is very welcome here. Do I have to go to advanced maybe? Oh, okay. In that case, so I think maybe just lowering the volume is probably the correct thing to do. I can see that my meter is going up. Now I'm in the yellow. When I reach the peaks, I'm still in yellow. Before I was in red. Maybe I should go even lower. How do people feel about that? So now, for example, now it's 43. It was 49 before. I'm going to go ahead with this volume and then we'll see sort of, hey, how do people feel? You know, we're going to have to take it piece by piece, like iteratively, right? So we want to, yeah, the example program. Okay. Well, how do people feel about the current situation? I mean, in terms of volume and peaks, blah, 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 etc. Because if OBS has this automatically, then I don't know how to change the like whatever is going on, right? I can only choose one audio encoder as well, and so on. Should I raise the bitrate of the audio? I mean, it's 160. You know, I could. I mean, I know it's annoying because I have like a slight lisp as well, right? Not like a really bad one, but when my S sounds are very. I know they can be very distinct. Let's now I can't talk without thinking about that particular thing. Yeah, I don't know. I don't know what to really do here. to be honest. Okay, so I should raise the volume again. Okay. It should be approximately what it was now. Anyway, I'm gonna have to figure out some kind of solution for the next stream, maybe. There will most likely be a next stream. So, actually, let's just do OS args 1 here, right? So, import core OS. By the way, I should note that my Odin version is dev 2026-02. If you're using OS, in dev 2026-03, they switched over to OS 2. If that means nothing to you, don't worry about it. It's not a big deal. There are two modules. There's OS 2 and there's OS. OS was the old version. OS 2 is the new version with a lot more control, a little bit more. They cleaned it up. It has other capabilities, a little bit better process control, etc. Or, well, it has process control at all, which OS does not. So if you're using these OS modules, just keep in mind that if you're on the latest version, you won't see the same functions as I am from OS. So this version here specifically has the old OS module. It won't matter for this program though, particularly. And also in general, you don't have to worry that much about this. So this is going to return a package. This is one of those awkward situations. So package is a keyword. Odin actually, at least last time, let's see, parse package. Okay, let's do this and we'll see how this sort of turns out, right? Yeah. So package is a keyword. So there are a few things you can do here that I dislike most of these. So the classic is you just say package like this, right? I don't like these types of things. I really do not like buff, package. I don't like message and so on. These, I just don't like variable names like this, right? You may as well spell this shit out, right? However, in this particular instance, the alternatives we have are really shit, right? So you may have seen stuff like this, package with KK, and so on instead. This is the same as if class is a keyword, you do class like this, which is actually class in Swedish. Klass, but you know, I don't like any of these. I'm just gonna do this, PKG. I'm giving up my principles, and that's it really. So if we can't parse this package, we're just gonna want to, I'm gonna make a function called fatal f here, and we're gonna say unable to parse package. Let's just do package path like this, and here we're gonna do package path like this. So here we're gonna take a format string, which is just a string, and then we're actually gonna do args, which is a .any. You don't need to do this. It's not necessarily, you don't have to do this always. So here we're also going to use caller location like this. Yeah, we're going to do that. So here we're going to do a few things. OS exit 1. I'm always exiting with error code 1. I don't really give a shit about error codes anymore in programs, to be completely honest. Here we're going to do printf ln. Yeah, we're going to do format just fmt string equals format. here we can actually do this. And then we can do .args, I think we should be able to do, and then lock equals lock, I think. It's not lock, it's location, probably. Oh, did this not have? Oh, it doesn't. Yeah. Okay. Ah, hang on. E is what we want actually. That also does not have a location, so never mind. Never mind. Actually, we don't need caller location here. We are building a just a simple CLI tool that basically parses an Odin package via Odin's own parser. And then spits out definitions. Basically, it's a lookup tool for spitting out which functions exist, what arguments, their signatures, and so on, as well as documentation for them in the long run, probably. And then, it's just a tool for doing that, basically. Johan, let's see. I tried to try Odin at some point, but it needed the whole Windows SDK stuff with Visual Studio. Yeah, so there's actually a pretty reasonably simple way of using the Odin compiler. So actually, I may as well show this now. Let's see. Yeah. Here we have portable MSVC. So this folder I have here, I actually use in order to compile for Windows on Linux. And you could do this on Windows as well. Hang on, what is Odin doc? Odin doc, let's see. Oh, well, Odin doc. Is that a command? Odin generates documentation from a directory of Odin file. Aha. Yeah. We're gonna just be spitting stuff out. Hang on. Let's see if we can get some help here so I can see. Let's say we were to do short. And we were pointing it at core net. Oh, right. Arguments go last. Yeah, I mean, this is this is actually kind of what we want, yeah. Yeah, this is not a bad example of what we want. The reason I'm doing this stream is so that I can show people how to use the Odin parser to a large degree. But in terms of the end result, now the stream, like I said, the purpose of the stream is simply not to, it's not just to get an end result, right? The end result will look a lot like this. Sure, it will. The purpose of the stream is not to make the tool, though, necessarily, just to be clear. But this is interesting. I actually didn't know about this. That's very good to have. So, let's just do fnt print diff. So if you want to print stuff out, oh, hang on, I was talking about something. Never mind. Before I got sidelined. Hang on. So ll, this directory here contains an MSVC installation, right? So here you'll find everything that is included in MSVC. so that you can then use it for Odin compilation. So I use this on Linux to produce Windows executables via Wine. I have a script called Odin. Let's see, we can take a look at this. Odin here, it's just a way to just call into effectively setting up the MSVC path, you know, as you do on Windows effectively, and then calling the Windows Odin binary in order to compile something. So whatever compilation arguments you've given it, that's what this $@ means here, right? So we're going to pass through the arguments to the script. That's all that's really going to happen. So I use this in order to produce Windows binaries that I can then run on Wine on Linux, right? So I can compile, you know, DirectX 12 binaries and stuff like this. It works beautifully. Now, the reason I'm saying this is not necessarily because everyone should be producing applications like that all over the place, right? It's actually more that you can do this on Windows as well. So you can use this portable MSVC script, which I don't remember where I got it from, but if you search on the Discord, you'll find it. So this portable MSVC Python script will actually pull down everything you need in order to have the MSVC suite, right? So that you can then use, you know, Odin on Windows without, you know, being bothered with the installer and everything for this. That's why I'm talking about all of this. It's not pointless. That's what I'm trying to say. So yeah. Oh, let's try this. So if I were to do this, right? So here we have, this is the content that we have in here. And we really don't need anything from sort of the top level here, right? We do need to pull things out of the files. So we're gonna do actually gonna do this. And here we're gonna do file path. Yeah. We can do this. This should be fine. Let's spit this information out. I don't normally have this kind of font size, by the way. It's significantly smaller normally, but I figure for the stream, a lot of people, I don't know, they're watching on phones and stuff, so it's very difficult to see anything. So here we have, what we really want is the declarations here. So what we're actually gonna do is we're gonna say this here. Just gonna do this. I'm not entirely sure that the documentation is actually included in this. That might actually be a little bit annoying. We'll see. Let's see. I had quickly tried to use this script, but it wasn't explained how to tell Odin where to find it. Yeah, actually. Yeah, so the thing that you have to do is you have to run this setup x64 bat file, right? So what that actually does, what it does normally on Windows and also is effectively it injects a bunch of basically dev tool path stuff and so on in your environment. So the normal thing to do is essentially have that always be run so that it's always injected into, for example, when you start a new terminal and stuff like this in Windows, and so on. Nothing is really necessarily figured out super automatically. Honestly, if you don't have to care about this now, good for you, to be honest. But development on Windows is very, it's just MSVC, as it stands. This situation was actually a little bit better on with Zig at some point, because you could use Muscle as well on Windows. So it was a lot nicer actually in that way, in that sense. Right, some stuff. Let's just add this here. I am curious here if, because we can actually check this now. Right, so line 23 is this one. So it does not get comments here. This declaration does not have its comment attached. That's a little bit annoying, to be honest. But yeah, we're not going to do documentation for now, I suppose. So 20, yeah, that's the end of that one. What I'm looking here is, I'm just looking at the results to line them up with what we're seeing in the file itself, right? So we would expect to see, so here you can see one of these ends on line 20, which is of course the main, right? And one of them starts on 23, which is of course fatal F. It would have been better for us if we could actually bake in the documentation here as well, but we cannot. That is not the thing. Curious if there is some kind of way so there's hang on, let me just double check some stuff here. So what I'm looking at right now is the Odin source code, right? And our biggest problem here is going to be finding out if we can actually, we can call something else to get the docs of some something. Otherwise, what we have to do, unfortunately, is basically implement some of our own parsing for that, which, as like a, hey, we're gonna add this feature, it's not that bad, but annoying. So this, yeah, GitHub does not understand Odin tokens, but if we were to say docs, oh, well. Can I make this even small? Well, no. Fuck it. Where is docs actually set? So hang on, are you passing actually docs to this? That is annoying though. What would that be even? This does not seem like something you want to call necessarily. I think a lot of these are simply, they're essentially internal functions, but they are exported. What is a proc tag? Oh yeah, okay, optional. Okay, yeah, okay, that makes sense. Yeah, we might have to implement something of our own. It's not a big deal. We'll deal with it at some point. Anyway, we have our declarations here, and these declarations are statement which is yeah, I think here, because let's see, right, so this is not a caseable type. However, I think one of these is. Yeah. So here, I think maybe we can take a look at the node actually. So derived proc lit. Let's see here. So if you want to check what a value is, what kind of type it is, could be, maybe, you want, maybe, don't remember exactly. So if you want to check what type something is, so what we did here is it's a type switch. So there are two switches. Switch, for example, value, like this, right? And when you do that, you are checking what is this, you know, for example, switch 5 here. Oh yeah, it's because this is not closed. You can do that. This is just a value here, right? Or you can do this, which is essentially we check which tag something it has, right? Which is when something is a union. So when something is a union, it's a tagged union, so it has a tag field, and then it has associated payloads with those tags. So under the hood, this is basically how it works. What we actually see on the surface, of course, is that we see just a union that is, it's one of these types. So, for example, in the case of this derived value here, if we go to any node here, we can see that this is a union. This means that any node as a type can be one of these. The tag is managed by Odin, in reality, right, under the hood. So let's see here. So we can do this, right? And here we could say case proc lit like this. And then we could say fmt printf ln proclit like this, and then we can spit out t here. And if I were to do this now, we will see that the compiler says, hey, you're not checking a bunch of values. So what we can do in these particular cases, here, by the way, we want Odin AST, something like that. Path does not exist. Okay, that's something else. This one. Right, so the complaint here is that we are not handling everything else at all, right? We are not dealing with it. What we can do in this particular case, we can say case, this is a default, but what you'll notice in this particular case is that we are not going to get rid of this warning. Just because you have a default does not mean that you're getting rid of the warning. What you can do when you are absolutely certain that it's not going to matter, you are testing the only one that you're interested in, is you can add hash partial like this. And if we run this now, we get this output, right? So here I'm going to remove this output. And so now we can see that we are not getting any output. In fact, this means that those are not proclits, right? So what we're going to do is we're going to say proc type okay, they are not those either. Case yeah, so what we can do is we can say fmt it's fun. Opa. Right, value decal. Okay. That is interesting. So 34. Yeah, it's okay. It's just a value decal. Case Odin AST value decal. So let's see what's in one of these bad boys. Oh, docs. That's interesting, right? Yes, we get docs. What a beautiful thing. We can toss that in immediately. In that case, so we might have to go a little bit deeper here, but things are looking really good. I'm going to take a look at the docs here actually, just to take a look at what that actually is. There you go. The docs are, we have this list value here, which is presumably just a slice with some tokens. We could easily just write a function that pulls this stuff out. Let's check what happens when we have multiple lines. Here is some more doc stuff. Okay, so we just merge we can merge the tokens here, right? The kind, we take all of the kind equals comments, or the comment kinds, right? We merge them together when we build the docs for a certain declaration, right? That will be good, presumably. So here we can actually take a look at what is this derived stuff. We can also take a look at the type field here. I did not build it. Oh, so the type field is nil for our value decals. That's interesting. We have the values here. It's possible here that derived might have something interesting for us. So what I'm actually going to do, by the way, is I'm going to task file. I'm going to add a run thing here. CMDs, task, build, and then we're also going to do bin lookup with dot, I think it is we're doing, right? Or lookup like this. Method none. So this is a task file for those who might not know, by the way. It's really just a way to set up like build steps and stuff like this. Nothing super interesting about that really. This is actually going to be lookup like this, and here we could add 2 stars like this. It should work just fine. So what I'm doing this for, if I do task run now, you'll see it runs the program, right? So we can do task run -- watch. Now whenever I save the file, it's going to hopefully just run this again, and there you go. Now I don't have to switch back and forth, and we are just doing stuff. So we have this derived statement, right? Value decal, which again is going to be right. So derived should be something that gives us something here. The name is interesting. Names, let's do this. Of type any node has no field names. Right. We're gonna have to unpack this as something else, right? Is this still a value decal perhaps? Let's see. So I'm going to pull this value out here. Here I can actually show value decal, and we can do is value decal like here. So what we did here, this is yet another way to check what a union actually is, right? So this is a union, this any node value here, as we know. If we want to check whether this is one of the tags, we can also do dot, parenthesis, and then which of the tags we are checking for. This boolean here will be set to true or false, depending on if it is actually that one. We can see that it's that one because we actually got output here for value decal again, right? So if it is that one, this value here will be non-zero, as in it will actually have content. Otherwise it will be zero, the zero value. Just like saying value decal here, Odin AST value decal. When we declare a variable like this, it's the zero value, right? Odin is always about the zero value. Always. Which is very nice. So what I want to do here, this obviously has names, right? Yes, it does. yeah, the name is really just the actual position, right, of the. So we can see here fatal F is ending on line 7, etc. So it's nothing super interesting there. It's just going to be the name, and we're going to have to reach into this file to get that, I suppose. Which is a little bit awkward, no? The value is interesting. Values 0 here. Now, what I'm gonna go ahead and guess is that this, right? We don't have to guess, of course. We can literally just check this. So here I'm on position 11. This happens to be the column where this starts. So line 41, we're on 41. We're on column 11. This is where this starts. Unfortunately for us, it only has the end position here. So in fact, what we might have to do is we might have to reach into this here, which I'm not super enthused about doing necessarily. But we can do that. That's fine as well. Odin parser walk. Wasn't there a thing? Let me just check a thing here. Yeah, no, parse package from path. I'm mostly just checking that I'm not missing something obvious here. I wrote this a fair amount ago, essentially solving a more interesting problem, I say. No, we're just gonna have to, you know, take a look at some of these things. So we have partial switch T and value declaration values derived expr. Sure. Let's just do some more of this, I suppose. Yep. Values dot derived. Right, now we're getting to the proclit. That's good news. This actually means we can look at the type. Probably. Motherfucker, okay. Never mind. But still though. So so hang on, let me yeah. So this is our derived, and here we want to basically do this. We're going to clean this up later, just to kind of pull out the actual relevant information we want. But now we're just writing some exploratory stuff. So here, what we actually want is a proclit is proclit. This is what we're interested in right now, which means that we are going to say value decal derived type proclit, this one. If is proclit import decal. So hang on, is this not a proclit maybe? That's annoying. Yeah, it definitely isn't. So this derived type in here is something else. Let's see here. We're gonna do this %v, and then we're gonna do type of. Here we might need to do type ID type of value decal derived. Though this might just print out only values can be casted. Cannot assign any node a type to type ID. This is not how you do this. Fuck, I don't remember now. No, this should definitely be something like this, no? Wow. It's confusing. Anyway. We can also use the reflect machinery for this. Let me just double check here. Package. Variant, union variant, raw tag. Yep. This should be fine. Type ID is really what we want, Sir Heather. So this is still a value decal. Hang on, did I make a mistake here with, yeah, of course I did. This is supposed to be values, no? Values. 0 derived proclit. Yep. Okay. It took a long time. So what do we have here? We have a bunch of stuff. We have the type, and what I really was interested in here was the type section of this. Because this effectively should allow us to pull out the actual type. Yep, it's this section here, which is great. So now we have that. What we can do, we can kind of try to clean up some of this process here, and let's think about this a little bit. The things we are interested in, we're interested in functions, well, procedures. This is a struct, it has a name, which is just a string really. It has a type, which we're going to say for now, or just in general, we're just going to say that that's a string because we're going to try to pull this information out, right? For now, this might be what we're settling with. We will want to add type here, right? But what we can do is we could say declarations. A declaration is a union of procedure and nothing else right now. We will then add type here, proc group, possibly, etc. But whatever. The reason we're doing this is because we are essentially just working with a, the problem is simply we get information from somewhere, we then turn that information that we care about, and that's really it, right? We're not concerned with what the internal representation of this is. We don't need to save that. We really don't need to care about it at all. So what we're actually concerned with is simply what we want out of this. So that's what we're going to do. Here we actually want docs, which we're going to also say is a string. If you really wanted some strong typing here, you would make distinct types out of these. So for example, if you were to want some kind of type safety around this, let's say we could make procedure name here. What that actually is a distinct string. Similarly, you could do this with all of these, right? So we could say docs here, we could say type here. Let's see, docs, type. And I like to have them in the same order for no reason at all. Now they are distinct, which means that you can't just take any string and put it there. You actually have to specifically say that this is a name. You have to say that it is a type. You have to say that they're docs, etc. What this actually helps with is if you have a lot of information flowing in your program and so on, if a function just takes 3 different strings, it can be very easy to put the wrong string in some position and so on. This helps with that. You end up in a situation where you can instead be very specific. So if I were to, for example, pass this information to a function that expected a name, a type, and docs in that order, I can't actually make the mistake. I can't pass the type as the first argument because it's simply not a name, right? If these were strings, we could make that mistake. This is sometimes called type blindness or whatever. It really comes from bool blindness, which is if you have a lot of arguments that are just bools or whatever passed to a procedure, it can be very difficult to see what exactly does that mean. And of course, you can help that in many ways. For example, if we have a function in Odin, we can simply say should allocate equals true, which helps with transmitting information like this. So this type of bool blindness we can actually get around in Odin pretty sensibly. But this problem is very general in a sense. If you just have these general types it can be easy to pass the wrong thing in the wrong position, and this actually has no runtime cost. The runtime representation of a procedure name is exactly that of a string, meaning there's really nothing in the runtime that actually, at runtime, that sets these apart. It's just a compile time issue. And that's what we want. Type safety is great when you can get it just like you pay for it at compile time to some degree. Don't get me wrong, I don't like long compile times. There are languages that I've used that have compile times from hell, and I'm not going back to that. That's over. We're done with that. So now we are going to pull out. We're going to pull out a declaration. From our decals. So for D in decals, right? So if decals is for every file, it goes through declarations, right? So get declaration will be a procedure that takes something and returns a declaration, which is a declaration like this. I like using named parameters, by the way, like this. They're really good for just when someone looks this up, they can see, oh, this returns the declaration. Of course, from the name in this particular instance, you could see this, no problem with that or whatever. Oftentimes it can be pretty easy to see, but I like them also because that also allows us to simply skip. It skips a line here like this. So when you have a named argument, you get an implicit stack declaration. A lot of these terms here get very confusing when we're dealing with actual declarations in our program, but rest assured, this is a declaration here of a value of type declaration. When we have that up here, we actually skip that step, so we don't need to worry about it. We have that value already. So we want to reach in, essentially as we have done below in this switch here. We want to reach into this value and say, this value, I want to make that a thing that I am interested in. So we would take this code, obviously remove some of this stuff. I think we can kind of just do this. Case here, we're going to do nothing. We're going to return declaration, by the way, like this. And because declaration is a union, and we don't have the tag no nil here. Oh, well, it is very similar to Go. That's why you feel that way. Sad MC. It's definitely similar to Go. In my mind, I don't know that it's an opinion necessarily. It's to me, it's mostly fact, but you know, whatever. There are a few languages that sort of obviously inspired the syntax of Odin. It's Golang. I don't know what Ginger Bill thinks of that. Whatever. That's my view on it. And it's Pascal. Also Modula, I suppose, to some extent, but I'm not entirely sure. I think I think Wirt reused syntax for Modula and Pascal, I think, probably. But yeah, so you have Pascal and you have Golang and probably a little bit of Jai in there to some extent, I suppose. But that part is, I think, vastly overstated. But, you know, whatever. People have all kinds of opinions and stuff on this. Like I said, my opinion is mostly Golang and Pascal. And that sort of, you know, is what it is. Let's see here. Right, so this declaration is a union. And if we don't have no nil here, there's an implicit case here. that says nil, like this. That means this is always a nullable value. That means that when we have a value of that type that we haven't assigned something to, it's going to be the 0 value, and the 0 value is nil. So this means when we do return declaration here, that is implicitly, because we haven't set anything in this code path, if we don't hit this value decal, it means this is going to be a nil value, right? That's what I wanted to get to. But I obviously took a very long time to get there. So let's see here. 24. Oh, right. We are going to pass declaration this is going to be a D like here, which is it's actually a statement. So let's do statement Odin AST STMT, something like that maybe. Let's see. Aaron. I've been learning Go, and one thing I've noticed is Go is very opinionated. The language kind of forces you to conform to certain ideas instead of being free to do anything like in C or C++. Yeah. Well, I'm not entirely sure. Okay, so you can view that a few different ways. So I obviously like freedom, which sounds like an odd statement to make or whatever, but I would say that there are different types of freedom in languages that are... So in C++, I would argue you have the freedom to overcomplicate things a great deal. It doesn't really... C++ doesn't really have a style, if you really think about it, right? So when I was learning C++, I learned first the normal C style stuff, and that kind of made sense, broadly speaking. And then when I learned it more, I learned, C++ stuff, and also like inheritance, class diagrams, and so on. And that stuff is, to be generous about it, it's not necessarily useful, right? It's pretty meh stuff. It really has almost nothing to do with, real programming, development, solution. Like if you want to write the solution to something, an inheritance diagram or whatever, I probably shouldn't really come up. In most cases, it's really not useful as a way of thinking about programming. It really just gets you further away from a workable solution in most cases. And in C++, you can just say, no, I'm just writing C. It's just that they're in C++ files, like the functions, the types, and so on. So you're free to do that. But you're also free to make the most insane, stupid, object-oriented programming-based code base that really just doesn't make any sense. Everything is spread out in 50 million files because everything is a class, and you have all of these insane things that can happen with a class and everything. And if you look at Golang or something like Odin, it's more stripped down, right? You just don't have the possibility of making these large inheritance diagrams and stuff. Well, what's the point? You just don't have that as a venue of development. So in that sense, you could say that's opinionated. And so I suppose maybe it is. I would argue that a language like Odin or Golang really is just trying to be the best procedural language it can be for you. It supports procedural code, imperative code, and that's it. That's all it really cares to do. It does not care to provide you with a bunch of, object-oriented, class-based solutions. Everything is a class, blah, 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 this and that, and so on. It also doesn't care to provide you with, interesting things like RAII, right? So resource acquisition is initialization, which is the worst acronym known to man. But so you could call that opinionated, and I suppose it could be, right? The opinion, I suppose, of the language is, I'm going to just be the best procedural language I can be for you. I don't really care to do anything else. So, take that for what you will, right? That's how I view these languages more than anything. It's really about that mostly. So here, what I actually would like to do, so declaration would be equal to a procedure. And here we know that we need to actually say procedure name, name equals procedure. Let's just do name, type equals type, docs equals docs. And here we would have to figure out what these things are. If you're really interested in having values that are sort of not defined yet in Odin, you can use this syntax here. You're not gonna actually have that work, but syntactically it will be fine. So I'm using these just as placeholders right now, because we're just interested in having the code here. We happen to know that these should be strings and so on under the hood, so we could effectively produce strings here. Yeah, I mean, not everyone agrees that object-oriented code is a bad decision, right? But it's effectively what some languages say is, we don't really care to provide you with all of these class structures and stuff. That's it. It's not that they're super opinionated in any other sense. Like, I would say maybe there are a few aspects of Golang that are opinionated. For example, they're very particular about Go format, Go thumped. Everyone just runs Go thumped, but there's no discussion about style. The style is no one's style. The style is Go thumped, effectively, which is a good decision, to be completely honest. It removes entire discussions about, how do we name things and so on. And they also bake that into the language, right? So, for example, instead of exporting things, manually, so to speak, things that have uppercase letters at the beginning are exported, which, that kind of makes sense. Odin doesn't do that, of course. But as a design decision, I think that kind of makes sense, to be completely honest. Because it's just, why do you need these discussions? Right? You really don't. Necessarily, right? So this is the type, and here I actually want to say yeah, we actually need the name from up here. The name should be, so let's say name start. I don't like this necessarily, but I'm gonna try to explain what I'm saying. The name is actually here, right? In names 0 here. And we actually get the pulse. These are our name starts and name ends. We need those, and we're getting them up here, and then we're sort of just moving on. The docs were not there, maybe. I'm actually not sure anymore. I think maybe we just check this. Yeah, not everyone liked that video, which I understand. It's difficult to explain without sounding like I'm surprised about this. I'm not surprised about this, but you know, a lot of people did not take kindly to some of the things I said in that video, which is fine, by the way. It's fine, absolutely fine. You know, some of the language used in that video was inflammatory. Some of it on purpose, honestly. I don't think people will listen, to be completely honest. There are so many ways I could have made that video super respectful and diplomatic, and no one would have seen it. But, you know, I'm not saying I'm trolling on purpose or whatever. I'm just saying that there is a certain amount here of, you do have to kind of say something that people will take notice of. Maybe it's kind of what I'm saying. Because, you know, it's just one of those things. But yeah, videos are tricky business. No, I mean what I meant what I said. It's mostly the tricky bit is just how you say that. That's really it. I think there's a version of gatekeeping, so to speak, where we really just hold people accountable for bad decisions and bad work. Right? That's maybe what the video should have said if it was trying to be very diplomatic, trying to be very nice to everyone, and so on and so forth. But like I said, not everyone will watch that video, and it won't spread. If it's just being diplomatic and so on. How many times, you know, how many times have people brought this stuff up? And they've been super nice. They've been very diplomatic, right? So at some point, a video that is a little bit more forceful, so to speak, in its language will, you know, potentially will be a little bit more, you know, it will have more of an effect on people sometimes. That's maybe what I'm trying to say. Oh, yeah. No, there are industries, of course, that they have gatekeeping built into the system. Right? So it's not as if our industry would necessarily be super different in that regard, I think. Yeah, Aaron. I mean, obviously, the bullying part was put there on purpose, perhaps misguided. You know, I'm not gonna say that all of the decisions I've made with that video were necessarily the absolute best. You know, but yeah, there are definitely, you know, if you look at what I actually said in that video, that in terms of what is the meaning, the spirit of that video. It doesn't necessarily align with some of the words that I use to describe these things, perhaps. But yeah, like I said, it's tricky business making videos. I'm not a YouTuber, so it can be a little bit difficult to navigate some of these things, especially when, I'll be honest, I was a little bit, you know, peeved when I made the video, obviously, right? So it's tricky. Some people tie their identities to these things, so probably felt attacked. Yeah, but if you were very diplomatic, you wouldn't have gone. Yeah, exactly, right. I think that it's just a trade-off. And fortunately, you know, I've read some less than savory things written about myself in different places. I saw in my analytics that the video had made it to Reddit, so I checked, you know, where on Reddit. That's interesting. And I saw that it ended up on Primogen's subreddit. And there were people, let's say there were people there who did not like me which is, you know, fair enough. Fortunately, I have grown thick enough skin to just sort of take that as for what it is, you know. But yeah, someone said I was doing meth, which I thought was interesting. You know, I don't know. That one was, you know, a very interesting take. I don't know where that came from, especially because I speak so slowly, honestly, right? And to say that I do meth is, you know, like, I could see if you thought I did some kind of other drug, you know, maybe that makes you kind of chill and what the fuck. But yeah, amphetamines, no, I'm not seeing it, you know. But yeah, people are funny also. There was someone who said I was bald maxing, which I found just hilarious. Like, sometimes these new things really just tickle, you know. They're just funny somehow, right? These types of things. And what was the other thing? People are funny. Like, a lot of them are just funny. Even though they clearly don't like me. It's just funny, some of the stuff that they're saying, right? The meth was more of a question mark. I was really not, you know, I wasn't 100% with that one. I didn't really get it. But, you know, bald maxing. Someone said they would gatekeep my head, presumably because of, you know. I thought that was funny also. But yeah, anyway. Making videos is an adventure in itself. Like I said, I'm not a YouTuber, so this is sort of like I'm a tourist in a way in some of these things, you know. Anyway, okay, we have the name start and end. Isn't there a way to get the I feel like there's a way to get this name and so on, right? Am I crazy? Like, this should just be a string that we just pull out, you know? String. But it's entirely possible that we simply won't. I can't find anything in the docs that would point to this necessarily. So we're just going to move on. Let's see here. Let's center ourselves. So the type, we also have type start and type end, right? Because we have proclit.type here. Yeah, okay, it's pause and end. I thought there was like a little bit of a difference here, but there isn't. So we have the type start, we have the type end at this point. And here, what we really would want to do, we could really just write the function here, right? Get name, you know, get file content, name start, name end. Here, what we really will want to do, I suppose, statement, does that have the file? It does not have the file, in fact. And the pause does not store, no, it stores the file, so we're fine, we're fine. So we'll get the file contents here, And that means we can also use get file content here. Type start, type end. Now, there might be a better way of doing this. Get file content. So here I really don't. Yeah, no, I don't like these arguments that I've given here necessarily. We're gonna do content string, by the way, and we're gonna say okay bool, like this. But what we actually want here is we probably want a handle instead. I really don't like the idea of opening the file twice. It's just annoying and stupid. What we could do is we could read in the entire file, sort of at the beginning of all of this, and then we could just slice into it, which is honestly, that's fair. That's kind of fair. Let's just do data is a byte slice here, and then we have start and end, which are these are pause types. Yeah. Let's just do Odin AST pause like this, right? Is that the actual tokenizer pause? Probably. Yes. Core Odin tokenizer. And here let's just do Odin tokenizer like this. And this is now tokenizer pause. So what we're actually just gonna do, I suppose, is we're gonna say return string of the slice into this data. Right, so we're gonna have a start here, which is obviously start dot honestly, just offset should do, probably. And then we're gonna have end.offset. And of course, here you could do all kinds of stuff to say like, hey, this actually needs to make sense. The good thing here is we can actually remove our OK bool. In fact, this entire function, when I'm looking at it right now, seems kind of pointless, to be completely honest, but it might grow, so we're not gonna inline it just yet. It might be that this becomes more involved, so we're not going to inline it. This is per declaration, and I don't really want to do that. I don't really want to do that way. So because you can see here that we're getting declaration, we're going to be getting the declaration down here. So it would be better for us to pull out the data up here from a file name, which we can find in file path. So this is going to give us the bytes, right? This is our file data and file read OK. If file read OK, here I'm just going to do fatal F because we don't really give a shit at the moment. Unable to read file like this. File path. So read the entire file from file name, returns only an OK bool. It doesn't do anything else, so that's unfortunate, but it is what it is. I think this should be fine. You know, I think so. We'll see. Declaration is going to be get declaration. And here we have our file data. And we have our statement, which is our D, like this. Declaration is not used. Printful. The docs here are not going to be valid. We're gonna give that the empty string for now. We're gonna remove some of these prints until we need to debug some stuff. Right, so here what we can do is just say this is a procedure name. So just to clarify what's going on at this particular moment, the reason we have a compilation error here now is because these are strings, right? These this name, this type, and so on. What we actually want, the thing we actually need is we need to cast these like this, and type is going to be here. And so now we're saying this is, of course, underneath it's a string, but what it represents is a procedure name. This means that any function that's using this information knows exactly what type they have, which means we can be a lot more specific about our types. Let's see. Get file content needs, of course, data here. And our docs are, of course, procedure docs. So here we can see we have a bunch of declarations that are nil, right? Because we're not getting anything for those values. We're returning nil because we're hitting the case where we are not setting this proc_lit value in this case. I'm going to add a return here. You don't need to do this, but because of course we are always returning out here, but I like to exit it as early as possible. So, you know, and in some cases we obviously are not getting a proc_lit value, meaning a function, a procedure, right? And in those cases we're getting declaration is nil up here, right? That's these cases here. Otherwise, we are actually getting a procedure, get file content, which we wrote before. We are getting the type of that, which is this value here. And we are not pulling out the docs. We have delayed that. We're deferring that until later. But it does seem that we are actually pretty good. We're pretty sensibly set up here already, right, to take advantage of this information. So this means effectively we can now move around in the file. We can find the things that are of interest to us and actually, you know, show them essentially at the moment. Are there any questions so far? Because the whole point of kind of doing this is honestly to show, one, how to use Odin's basic parser, just to gain information about your Odin packages. It's pretty straightforward stuff, and it really, you know, it makes a lot of sense, I would say. How to use it, what you can gain from it. It's a little bit of a, you know, it can look a little bit messy, obviously, but if you're, for example, if you're using the kind of method of working with it that I've shown so far, you know, print out stuff, explore the stuff, you know, as much as you can by just saying, hey, what do I actually literally have right here? What content does that mean, etc., and so on. Because that's always a good idea, right? It's always a good idea to actually look at what actual data do I have. That's the only thing that actually matters, right? You can have a beautiful solution that depends on data that you're not going to have, and you don't have a solution because it's simply pointless. Here we're working with exactly the data that we are looking at, which means we are getting exactly what we need, and so on. Now I'm curious if maybe we can say docs here. We cannot say docs here. In fact, that's attached to the name, probably. Value deco docs. Printful. Yeah, we're gonna do if docs. Yeah, well, I'm gonna set up some bullshit here, and we're gonna have to deal with like, oh, this will be ugly first, and then we'll deal with it. Yeah. That's interesting. Docs is a comment group. I'm not setting these anywhere. What am I doing? Jesus Christ. Docs start. Docs end. There you go. We are building just a tool that spits out some information about Odin packages, basically. Just to show how we can use the Odin parser that's in the standard library to inspect Odin code, get information out of it. In a later stream, I will use this to output serialization information, serialization functions and deserialization. So for context, for a project, I wrote a tool that automatically spits out serialization, deserialization functions, because if you try to do this with reflection and other mechanisms, you end up with incredibly slow code. And so what you can do instead is you just say, you point a tool at a package, that tool spits out Odin functions that write to a binary slice, a byte slice. So they write to a byte slice, they read from a byte slice, and what they're reading is actually Odin values. And they know how, in which order to read these because you've generated them from real types. So for example, if you have a struct type and it includes an int and a string, you would read 8 bytes for the int, and then you would of course try to read the string, which is, you know, a length and blah, blah, blah. So, you know, what we're going to get to in the long run, what I'm hoping with this, is we're going to have a stream that does that. Right now, I wanted a much more slimmed down use case where I'm showing what we can do with Odin's parser. Just out of the box, what we can get with the Odin parser, we can construct our own information, right? So what we've done so far, let me just remove some gunk from this here. So what we've done so far is we have essentially made a tool that pulls out procedures from a package and so on. So we can do that. That's basically what we have so far. What we can do with these is we can, of course, now we can take this information and output it however we see fit. What I was thinking is effectively I mean, in some sense, we've already kind of accomplished what we were trying to do here. We could now output markdown tables. We could output just a list of things, whatever we really want to, right? The real kind of value here that I'm seeing from this is trying to show that the Odin parser that is in the standard library is very straightforward to use. If you just look at it from the perspective of, okay, exploring the data and seeing, hey, what is where, how is it stored, in what circumstances, is this set, and so on. Once you do that, you then can, you can actually get something out of it pretty easily, straightforwardly. And a lot of this stuff, I'll be honest, is stuff you can also copy paste, to be completely honest. Once you've written this particular section, getting function information out of files is now super easy for you. You really can get whatever you want out of this at that point, right? There's a lot more to declarations in Odin that we could look at, like tags and these proc tags and stuff like this. But at the same time, it's, if you want some basic information out of the parser, you really can get it pretty straightforwardly. But yeah, are there any questions about this stuff? This, by the way, is I said this in the beginning of the stream, but of course not everyone was here. I haven't streamed in a very long time, so I am coming back to it now. This is the point of this stream, is also kind of to ease into the whole thing, streaming also, right? So it's not necessarily that we're sitting here in hardcore trying to do something. That's not really the point. The point is also to just hang out, to be completely honest. I would love to just honestly spend the rest of the stream just having a conversation with people. And also, if there are, general questions about Odin, I'm happy to answer those as well. Especially because, I'm assuming there's at least, a couple people here who haven't watched my previous videos, might not know anything about Odin, in fact. And of course, that's my bread and butter is Odin. So, it's it would be nice if a lot of these, let's say, new viewers or whatever you want to, it would be nice if people liked Odin, right, and were interested in Odin. And it's obviously my favorite language. And also in the video that I posted, I do say, I pretty much say that everything is garbage. So it might be interesting to people to know what I don't think is garbage. I suppose. Not that it matters, to be completely honest, but what other people think when it comes to stuff like this doesn't generally matter, I would say. Which might sound odd coming from someone who made that video, but that's a little bit deeper than just sort of, I don't like your language, right? If I say to someone, I don't like Rust, what they really should take from that is, I don't like Rust, and that's fine in the end, because it doesn't really matter like what other people think. It also doesn't matter like what I see a lot of people in the Odin. Well, not a lot of people, but every once in a while you'll find someone who desperately wants Odin to become popular. And realistically, this is not going to happen. Right? It's not a language that I think really can become super popular. Not that it doesn't deserve to. But languages, there's a lot of them, let's be honest. And one of Odin's, one of Odin's biggest rivals, if you will, I don't really view it like that, but it's the best word for it, is Zig, right? And Zig became quite popular at some point. Well, for a very, very small alternative to C, it became very popular. That's how I will say it. And if you're competing with Zig, it might just be a tough time, you know. I know which one I prefer, and I prefer it for good reasons in my mind. But at the same time, you know, it's not really about what's good and what's better than something else and what all of the upsides are. A lot of language stuff really comes down to sort of the rich get richer and so on, a little bit. In terms of big projects, I've worked on, I was on contract for about, I guess, 2-ish years recently on a product written in Odin, entirely in Odin. And so what that featured was, in the beginning, it featured a server and a client written in Odin, and then an IM-GUI application. And then we made it local only, and with a 3D engine that I wrote for that. That was about, I mean, in terms of size, I would say it was very a tractable code base. I think the actual maximum size of the repo was 100K lines or something like that. And that was, you know, it was the application, the actual program itself, like the product, right? Together with the renderer that I wrote, the 3D engine. That was OpenGL, DirectX 12, Vulkan, and Metal. Varying sizes, of course. Like the Vulkan code was more than the others. That's what I will say about that. What bothers me about the language? So, okay, the first question I guess that you actually asked was, what does it feel like to work on a big project? I don't think that project was big, but it's the biggest that I have for you. So, you know, that's the only thing I can really come up with. But what does it feel like to work on a big project? Well, I've never ever worked with a code base that was as nice as that one. That's what I will say. The way that we developed that code was, the focus was a lot on simplicity, right? Making the simplest thing that could possibly work for basically everything. Making most things ourselves, the vast majority of things ourselves. So we have control over it. We can understand it. We can, you know, we can deal with it, and so on. This did not include the UI layer. Of course, we had 3D UI, which I wrote entirely from scratch, of course. But the 2D UI was with IM-GUI, right? So from that perspective, the UI portion was just IM-GUI. It's whatever you've seen before, right? And yeah, I would say that it was an incredibly easy, straightforward experience overall. The simplicity of Odin really, and we use approximately, I would say, 40% of Odin. There's a lot of features in Odin that you simply don't, well, there's not a lot of features that you don't need, but you really don't need proc groups, for example. You don't need the deferred in, deferred out keywords. Like, it's very specialized things, specialized circumstances. You don't need the using keyword at all. You don't really need to do any kind of interesting, like, object-oriented stuff, obviously. Now, you could argue that some parts of our stuff, like some parts of our code base, were object-oriented. And what I think my colleague and I kind of agreed on was that it's not necessarily object-oriented, it's context-oriented. So you can have, for example, a context value that gets passed around in some fashion and so on. We don't tend to store things in small objects necessarily and have them be, you know, little interesting objects and so on. The things that I would say annoyed me the most about working on that code base was the tools. So OLS is great. overall. But in our code base, OLS would crash for me while working on the renderer maybe 3 times a day. And that was kind of doable. I mean, it's not, it's not the end of the world, but it's annoying. And my colleague, however, it would crash on the order of, instead of 3, it's 30 every day, right? And this became an issue. At some point, it can be difficult to just do work at that point. Because if you use something that relies on OLS a lot, then you're obviously going to have issues in that situation. And so from that perspective, the tools that we were using, the Odin tools, left a lot to be desired sometimes. That's what I would say. And this is why I personally ended up re-implementing things in a more, let's say, simple way. So I made this task generation program, tag generation program that generates C tags so they can be used in NeoVim and Vim. So for example, when I do search, here, for example, we might look for matrix normalize. Yeah, sure. Ortho normalize, whatever. Matrix normalize, right? We might look at that for that function. We might want to go to it, right? And I'm interested in the F32 version here. So also, if I go to definition, if I go to this here, and so on, this does not use OLS for me. It uses tags instead. So Vim tags, C tags, they're called. And I wrote a program to generate those from a code base because OLS was so unreliable at some point. I still wanted symbol search. I still wanted go to definition and so on and so forth, right? And again, I just wrote some tools that dealt with that instead and so on. And one part of this is, of course, also if you, we don't get any updates here apparently. So sometimes when you use a language server, you get these real-time updates and so on, right? That also, of course, became an issue because, well, I can't get those when OLS is broken. So what I ended up doing was I built a small build system in NeoVim that allows me to run tasks. These tasks are defined in a very simple Lua file that just defines these, and I have a tiny plugin that does this stuff. And so here, for example, generate tags literally just runs tags and then, spits them out into the tags file, and here are the packages that we get and so on. So when I get this menu here, what that really is just looking into that file and figuring out like, hey, this is the task. So I press enter here, we run the task stuff. These errors are from the Odin parser, actually, and so on. So what I ended up doing was effectively, saying, okay, our tools don't really work. So the one problem with that is that a lot of the tools that we have work like elevators. So when an elevator is broken, you can't get where you're trying to go. But when an escalator is broken, it becomes stairs instead. And so what I really wanted was a set of stairs that I could actually go up when the elevator was broken. That's basically what I ended up doing. That's what these tools actually represent. So this build tool, by the way, let's say we did have a problem here. So I save here, and of course we can see we have a compilation error at the right side, but we can also pick the build action here, and it will show us an actual window here on top of everything with the actual error. Oftentimes it can be you can just look here because we have this ghost text here as well on top of or to the side of the document. So we can say, we can get something out of that. In this particular case, the error is not particularly great, I will say. So you might not know from that. But yeah, so when we do this, now we can build again, and that will disappear. And it also integrates with, so for example, if I were to do this here, let's say we have 2 errors, I guess. I also can get quick list support. So I can jump between my errors. Opa. So if I want to jump between them, I can do that as well. And let's see here. Is it queue list? Does anyone know? I don't remember what the quick. Wow, I should remember this. This is actually embarrassing. But you can go to the quick list and actually get this, get all this stuff. Like you can get a list of the errors effectively and jump between them and so on. Actually, hang on, let me just check this. Open quick list. Quick fix. Sure, I suppose. Is it C open? Yeah, so here's the quick list, right? You can jump between your errors and so on. When you have quick list support, you can effectively do this. We could also press enter to go to one of these. So even if you have them in separate files and so on, you can get them like that. So yeah, does that answer the question? The biggest issue really was the tools around everything, to be completely honest. The language itself, never used anything that made me more productive than Odin, to be completely honest. Mostly because it just gets out of your way, right? You can just make the thing that you need. It's very straightforward that way. Thank you for the question. I mean, these are good questions. Part of why I'm here is really this kind of thing, right? If someone's wondering about something and I can answer it, I'll definitely, answer it. I'll try my best. In terms of what I actually like about Odin the most, like I said, it gets out of your way. That's obviously a thing. And I like to look at languages from a perspective of what am I gaining here from using this thing and what am I paying? And so the paying part is something that people usually ignore, which I think is a mistake. What you really need to consider with a lot of languages, right? So I used to be really into Haskell as an example, and I love Haskell. It's a fantastic language in principle, right? But there are things in Haskell that simply, they don't need to be interesting, but they are interesting. Error handling is one of those things. So Haskell has exceptions, right? And functional programmers hate exceptions. Haskell also does not built in have any mechanism for checked exceptions. So for those who might not know, checked exceptions are effectively, they're exceptions that are more like tagged unions in a way. So you can kind of exhaustively check for which exception you have. Java has these, but they don't really use them. They hate them. I don't know what the problem with the Java version is, but in principle, checked exceptions are essentially an exhaustive list of errors that can happen inside of a certain code path. But yet, anyway, so Haskell does not have checked exceptions. It just has exceptions. So what you end up with, if you really just want to do what Haskell kind of thinks you should do from, the outset, is you use exceptions. And people have spent a long time building things on top of error handling. They've built interesting monads that automatically catch exceptions and make them into values according to some blah, 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 this and that. And there's just, when you get into error handling in Haskell, it is a jungle of different things to learn, ways of doing things, and all of them are interesting. And that's the problem, right? Haskell actually doesn't have the problems that people think it has. Like, there's just so much lore about Haskell out there that, oh, category theory, this and that. I could teach almost anyone in a month to write industrial Haskell programs. That's not really the issue, right? And there's no category theory involved. Like, you don't need that at all. But the problem with Haskell is that things that really shouldn't be all that interesting are just interesting, like error handling, for example. Like, there's no need for error handling to be that interesting, and so on. And people have written solutions, like there are space technology solutions, like they've added effectively, if someone knows what row types are, they've kind of added those to Haskell. A row type is effectively kind of a type level object with labels and values. So if you think about a JavaScript object, what that is, it's a string mapped to some value of some sort, right? And they've added row types to Haskell via interesting mechanisms and so on that you can then use in order to build up a possible set of errors and so on. Now, there's a language called PureScript that has this by default. It has row types and so on, where eventually they did the opposite. They went from handling errors with row types to simply saying, nah, or well, they handled effects actually with row types, but then they said, fuck this. This is way too much. And so we're gonna skip the row types for effects and so on. And, you know, all of this just to say that, you know, my main problem with Haskell and languages like it is that, you know, these things are not supposed to be interesting. You're supposed to just be able to handle your errors with a pretty straightforward standard way, and that's it. And if I look at Odin, for example, that is exactly what we have. We have error handling that is, sometimes it's a bool. Sometimes you have a union type. That is the error. Both of these mechanisms work really well with the language. And they have all the facilities you need in order to write straightforward code that exits when there's an error. If you want to bubble that up very simply with the or return keyword, and so on and so forth. And you have or else if you want to put a default value if there was an error and so on, stuff like this, right? And so that's how error handling should be. There is a straightforward solution that really is just an upgrade from C, and that's it. So what you pay if you use Haskell is you have so many things you can learn about things that really are not supposed to be very interesting, but here you are, right? Here you're sitting there for 2 days trying to figure out what the fuck is the best way to handle errors in this language. When in Odin, what you can really just do is watch my video on error handling, and I'm pretty sure you'll just get it, right? It's silly that we would need more, right? It's silly that we would need more than that. And that's really kind of my problem with certain languages and so on. Rust is a lot like this. There's so much you can learn about things that really are not supposed to be all that interesting, right? They have all of these libraries for error handling and so on. You know what? It's just fuck all of that, right? Just a bunch of nonsense in the end. Right, so Simeon, by the way, are you from Bulgaria? One question for the project in Odin you mentioned that you worked on before. What was the compilation speed when the project start to have more files and more libraries? Zdrasti. I live in Bulgaria. You might not have known that. So let me just take a look here. Let's see, Odin build, guys. Task build. Right, so if we're doing a normal, let's say we're building DX12, well, let's say we're building the Vulkan layer with the renderer here, right? Oh, motherfucker, okay. Yeah, this is going through the Windows code path. And I have compilation errors here because I upgraded my... oh, actually, hang on. That's interesting. Let me just... Ah. I don't know. I do have some problems here based on this, I guess. That's unfortunate. Let me just check this off screen because this is not my code, ostensibly, right? Where am I gonna put you guys? Hang on. Just a black screen. That's it. So let me just check here real quick. Oh, hang on. Okay, it did build. Let me just check here real quick. So let me show this compilation speed, I suppose. Here we're gonna build the DX12 version. This does not include shaders, by the way. There you go. These should only be warnings, I think. I'm not sure. Anyway, yeah. The build times, I would say, were manageable, but not great. Is how I would say it, for the most part. Right now, I can't give you like a 100% straightforward answer because, again, my Odin version is upgraded, and this project I haven't worked on it for a little bit, so I haven't upgraded it to the latest. We were running on 2025.06 or something, last I checked, and so on. Now I have 2026.02 installed. But yeah, the compilation speed, one problem is that you're dealing with LLVM, right? And LLVM is not fast, that's what I would say. It's just depressingly slow sometimes. I would say that the debug builds have been manageable at 100K, for sure. We're talking seconds still, right? And that includes IMGUI also, so it's like it's more than 100K, I suppose. I don't know. But yeah, manageable, decent is what I would say. Not nearly as bad as we would have with something like C++ or whatever, or certainly Rust. Odin is on the lower end, I would say. Let's see. Oh no, I'm on Linux now. When I was working on this, I was on Windows though. But when I build this here, I actually build the Windows executable. right? So, you know, I still produce things for Windows, but I do it on Linux. You know. Yeah. The when you do an optimized build, it obviously takes a lot more time. Certainly, it's fine, but you know, it takes a lot more time. You wouldn't do that for development, certainly. It's better to write mostly sensible code that can run in debug, right, when you don't optimize at all. Which is one of those things. You can't rely only on O speed to make it workable, right? You should be able to run the application in debug, and it should work fine. Otherwise, you're probably going to have a little bit of a tiring time iterating on everything, in my mind. Yeah. Oh, Golang. Golang is a fast compiler, I would say. Now, in Golang's case, they actually do less stuff than other compilers. So, you know, it's not an apples to apples comparison. OCaml, also a very fast compiler. OCaml is exceedingly simple. It's a very simple language. They also have rules that make it a lot easier to compile. Everything has to come in order. For example, you can't define things in any order you want and so on. Well, you can with keywords and blah, blah, blah. But OCaml is a very fast compiler. Golang is a fast compiler. Turbo Pascal is a very fast compiler. Probably the fastest, maybe. But yeah, I would say those are, I mean, obviously C as a language does lend itself to, in some cases, to fast compilation, I will say. Also, like there are compilers that can do a reasonably competent job with C, but you know, that one is difficult to say. Yeah. O speed, obviously, like when you need it, you need it. Like you want those optimizations to say like, here's what it actually will be, obviously. But from the perspective of iterating really quickly on things, I really, really, really wanted, want a debug version with no optimizations to be runnable, really very runnable. So I can just iterate fast on everything, right? Because, yeah, once you get to O speed, it becomes a little bit tedious. Jai would also be a language that has a fast compiler, but I wouldn't know. I've never used Jai. To me, Jai is, whatever. It exists, I suppose, in some sense, but not to me, right? I don't have access to it, so... I'm not really going to make any judgments on Jai, neither positive nor negative, because the truth is it's just a thing that exists theoretically in some sense to me. And some people use it, obviously. And for them, it's, it exists. But yeah, not to me. So, but yeah, Jai, obviously... John Blow really took great care to actually prioritize compilation speed, because he understands that it's really, really, really fucking tedious to be working on stuff and sit there and wait. Like, no one who's used C++ is going to not think about this, right? Yeah. I think it makes a lot of sense that Jai would be fast to compile. And the speeds that I saw... what was it, like 100k lines? No, it was more even, like a few 100k lines per second. And those are good speeds. I like those speeds. Maybe it's 1 million lines a second. Actually, I'm not up to date with Jai. Yeah, well, I have found with Rust, you have to reorient your thinking to be fine with the compilation times in Rust often. Some of the incremental builds, I guess, could be fine, but I found that there were way too many situations where I was paying way too much of a cost with Rust. Like, as soon as you add serde to a program, period, it felt like, at least, the compile time just shot up to like 5 seconds all of a sudden. Like with no code. We're talking a program that would build instantly in Odin. Suddenly builds in like 5 seconds. And you're like, why? What do you mean? I just added a derive for this serde bullshit. Because everyone uses serde and it's like, you know, you can probably write Rust in a way that makes sense compile time wise, but it's the same thing as Haskell. The problem is simply you have too much in the language, you have too many features that are added without thinking about compile times and so on. And so you end up in situations where it's like you're just paying a bunch of fucking cost all the time. You import the wrong library, you use the wrong derive statement, you use template Haskell or whatever, right? Both of those languages have these pitfalls. It's the same as C++. Use the wrong language feature in C++, all of a sudden your compile time is just fucking at the moon. For no reason. Like, no good reason. Yeah. I don't know. It's, compile times are really... I'm happy Odin is at least on like the right side of this, is what I would say. Is my impression. And obviously they're trying to make it better. It's just a lot of work to, you know, implement, you know, their own, essentially a compilation to machine language that is straightforward enough where you can just have that as your debug compilation, right? Haskell is at least very writable on paper, so that's nice. It's I like Haskell. Like, in principle, I like Haskell, but like I said during the stream, there are just things about Haskell that just don't make sense for software development. And mind you, before anyone thinks any different, because I keep stumbling upon this, is people have this idea that OCaml is like pragmatic or whatever. Haskell is a lot more pragmatic than OCaml, to be completely honest, in reality. Right? It has more features that you want for actual modern development. It has a scheduler, a preemptive scheduler, and so on, for actually dealing with threads in a reasonably high level way for essentially modern development and so on. Now, do I prefer that model of development nowadays? No, I do not. But that doesn't mean that OCaml somehow is relevant, right? OCaml is one of the least relevant languages that I know of. And I've used it in production, by the way. So it's not as if I'm saying this from, you know, nowhere. It's also a real heartbreaker of a language because OCaml is one of those languages that it was supposed to have all of these features like 15 years ago. But we've been saying that it's coming soon for so long that it's just like, whatever, dude. I don't give a shit anymore. There are so many much better languages nowadays. Like, there was a time when I actually thought, hey, OCaml might be relevant, you know. But in a landscape where you have Zig, for example, you have Odin, to some extent you have Rust, right? I mean, I probably like Rust maybe more than I like OCaml for most things, to be completely honest. So OCaml has become irrelevant because it simply doesn't win anywhere. Like, it's not really as good of a high-level language as Haskell is. It has a runtime that still sort of is from the 90s, in a way. I mean, okay, it's in the 2000s now, I guess, right? But I don't know, it's just basically irrelevant as a language, to be completely honest. Sure, Jane Street they've done a lot with OCaml. You know, yeah. Facebook has done a lot with PHP. It's one of those situations where everyone really just the only thing they can point to is Jane Street mostly. And I'm not saying that's what you're doing now, by the way, but it's one of those things. Yeah, that's basically okay. I actually kept track of the job market for around about like 5 years in a row, around 2017 to 2022, and constantly Haskell was had far more jobs than OCaml. So we can talk about Jane Street, or we can talk about like what are people actually doing. And why would they be using Haskell? It's not because they love category theory. It's because it's a runtime that actually helps you write applications in comparison to OCaml, right? So, that's my view on it. Again, I wouldn't prefer Haskell over Odin or whatever. I really don't. But I wouldn't prefer OCaml over almost anything else either. It's like there's always a better alternative to OCaml. For whatever you're doing, pick another language. I mean, come on. Even F#. That's kind of my view on that. But yeah, I guess I'm an OCaml hater in the end. It's whatever. This goes back to what I was saying in the beginning of the stream as well, right? My opinion on something really shouldn't matter to most people anyway. If someone really loves OCaml, they're doing super interesting, good stuff with OCaml, yeah, more power to them. They should just continue doing good work in the end, right? Have fun. There are so many languages that I would never really sit down and want to use in production. And there are people who are expert at those languages, and that's what they should be using. Yeah. Yes, that is the meme, indeed. But yeah, so for example, I think macros are a big mistake in programming in general. Once you get access to macros, and I used to be really into a language called Racket, which is a scheme. And all schemes are based on the idea that you have a few core forms, and then everything else is basically just a macro that takes those core forms and does something, basically, right? Macros in Lisp are a lot better than macros in C and so on, in terms of, especially in scheme, they're hygienic, which means you cannot refer to things in macros that don't exist and so on. You have symbol generation that is proper and good, blah, 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 all of those things. Point being, though, macros are magic, right? They're these tiny programs that rewrite syntax into something else and so on. This sounds good, but I really don't think it's a good idea. Like in general, like just as a concept, no. I think it just tends to scale really badly. However, if I were to hire 4 people, and these 4 people are, common Lisp experts, I wouldn't force them to use Odin, because that's fucking stupid, right? You would then say, do the absolute best you can with the language that you love, and you'll be more productive, obviously, because you're getting to use common Lisp. Obviously, it's free real estate, right? Because you see a lot of people, I think, that don't understand this. They think somehow, we're going to use, X or Y or Z because that's what responsible people use or whatever. Well, have you considered that maybe your people are really, really good at Elixir, for example? You have 4 people here who are really good at Elixir. They can make almost anything in this language. And you're somehow forcing them to use Kotlin because you think the JVM is a good thing. Fucking why? It doesn't make any sense. But a lot of people think like that. They're stupid. There's no other way to really say it. They're just stupid, right? And I would be stupid if I said like, you're obviously going to use Odin. These common Lisp programmers are going to sit down and use something that offends them to their very core, or whatever. Or at the very least, it's not the thing that they're most comfortable with. And you don't get good stuff by having people use things that they just don't really like. You get good stuff from having people who enjoy what they're doing, and they love what they're doing, and they want to do a good job. And these people would want to prove to me that Common Lisp is the best language, obviously. So it's in my best interest to have these people use Common Lisp. Now, don't take that out of context. That's not my general view of things. But, you know, if you have Common Lisp programmers, let them use Common Lisp. That's what I would say. Which I think makes a lot of sense. But yeah, that's just me. What's everyone's favorite language? What have people used in the chat? Radishen, Rouge, Sad Smile Games. I'm not trying to have a language debate or whatever. If it's OCaml, you don't have to say anything, it's fine. If it's OCaml, you can also say I'm just a moron. Oh yeah. Elixir is definitely too dependent on Phoenix. It's a lot like Ruby and Ruby on Rails. Right? The truth is, Elixir is a fantastic language to build systems in terms of if you can keep the lines of code under a certain limit, because it gets unmanageable at some point for me. My brain is not big enough to deal with dynamically typed stuff and so on at a certain scale. But, you know, beyond that, Elixir is really fantastic. That's because of Erlang. Erlang is fantastic for building systems in. C, okay. C and Odin is what I'm saying. Some JavaScript. Yeah, I think in the video that I talked, you know, there obviously I made the point that this sucks, that's garbage or whatever, right? The truth is, like I said in one of the comments, in principles, there's nothing wrong with any language, really, right? It's not that any one language is bad. It's usually the things that they engender, right? So the things that they promote as ways of doing things, that's really the big problem to me, you know. In terms of getting a job, if the only thing is getting a job, I would say Java would be a pretty sensible choice. Golang is popular enough, certainly. Golang is also, I like Golang. I like Go as a language. It's fine. Also, I like that the community of Golang, they don't really fuck around with building space stations out of everything as well. It's pretty straightforward. Standard library is good. Lots of good networking stuff in there. The networking stuff is built in part by Brad Fitzpatrick, and he's excellent. So yeah, Golang is probably, I would say it's the most popular language that I actually kind of like. Certainly. Lua, yeah. My problem with Lua is, you know, I use it in context where it's difficult to deal with, is what I would say. I use it only for NeoVim, Lua, and whenever I write a plugin for NeoVim, I always regret my decision. It's Lua is a mixed bag, you know, like I don't really like dynamically typed languages, and Lua is this particular type of dynamically typed that just feels like it's too flimsy in many ways. Way too flimsy. That's what I would say. Yeah, Go has a lot of principles going for it, right? People are sensible. People are mostly sensible when it comes to Go. I like that they're not. They just have better ideas, is what I would say, than a lot of different other communities. When it comes to, how complex should things be? Do we build things ourselves and stuff like this? Golang is a lot more sensible when it comes to a lot of those ideas. Swift is actually not bad, yeah. I kind of like a lot of parts of Swift, but I think it's unfortunate the positioning of Swift in the world. Maybe is what I would say. It got stuck kind of being a Mac language or whatever, an Apple thing, and then I don't know. It's an awkward. It's an awkward language for the positioning that they have. It's awkward for a lot of stuff, I would say. Rust. It's fairly obvious what I think about Rust at this point, I suppose. I've probably talked about it. So unless someone else wants to be filled in, we're just going to skip that. I don't super like being mega negative all the time. It might seem odd, but I don't like complaining about things too much. Oh yeah. Oh, in terms of the job market, Rust does not have as big of a job market as you might think. That's what I would say. It's probably getting better, but there's a lot of talk about Rust. There's less doing when it comes to Rust, is what I would say, unfortunately, for Rust people. Yeah, I'm not saying that Swift is unusable on other platforms. It's just their positioning. They made it awkward, right? I think Apple originally probably wanted to make it the Apple language, and they thought somehow that people would switch, but no one switched, right? It's sort of like Metal. No one has switched to Apple stuff for Metal. Metal is a great API, sort of. It's the closest thing we have to OpenGL nowadays. Sort of. It's like OpenGL grew up and became a little bit more modern, but it's still actually pretty good, and you can get a lot done in not that much code and so on. But the truth is they should have just kept OpenGL on macOS. Yeah, in terms of Shasharma, I would say your best. Okay, so there are a few things that are going to go into this, what I'm going to say now. You have to consider some things, right? How easy it is to get into something, and how easy it is to get a job, and how easy it is to work with something longer term, if you might be a caveman like me, for example. So Go is good because you can learn Go very quickly. I would argue you can learn Go in a couple of weeks. And I have some friends who think I'm wrong when I say that, but I'll be honest. With some concentrated learning and so on, I think you can learn Go incredibly quickly, especially compared to other languages, right? So you can learn Go in a couple of weeks, is my personal view. You can then get a job working with Go, right? That job is unlikely to become a nightmare of abstraction hell and so on. It's less likely than other languages, is what I would say. So if you get into Go, you focus on learning the sort of basic stuff. You add a little bit of, the less basic stuff. You read code from the standard library. They have exceptional standard library code that you can learn from. It's as simple as it needs to be in many cases. And then I think you can get a job and you can keep a job with Go pretty straightforwardly. What I will say is that there are parts of it that I don't really like. Like the error handling is, once you've used Odin, I don't think the error handling makes sense anymore in Golang, right? This idea that you have like this error type that you're supposed to wrangle all the time. You don't have any good features that allow you to just bubble up errors when they happen. In Odin, we have or return. We also have tagged unions for errors and so on. So it just is a lot nicer that way. And that's the only part that I don't like about Go. That's what I will say. And also, of course, I don't like garbage collection as a concept, but that's sometimes garbage collection is fine. I mean, just whatever. Yeah, that's what I would say. I think Golang wins on, if you look at it holistically, Golang is a good choice. It's better than, for example, yeah, of course there are many C++ jobs out there, but how likely are you to end up in a complete nightmare of a code base in C++? Incredibly likely. On top of that, you cannot learn C++ in less than years. And I mean that 100% fully. I used C++ almost exclusively from 2001 to about like 2010. You can't learn C++ without actually putting years into it. It's just not that doable. Can you end up in a code base that uses just like exactly these features and you can learn exactly those? Sure. But with Golang, that's just the default, right? You can just learn Go and then that's it. You don't have to learn a specific subset of the language. You can just learn Go and then that's the language. Yeah, now you know it. Now you can just go get a job in it and you can actually do that job. And the code that you see out in the wild is just whatever you learned. And so on. So there are different axes on which to determine, is this a good language for me to learn, right? And a lot of those actually also depend on like, what is it that you want to do? I learned at some point that I do not want to, the problems that I want to have are client-side problems. They are problems of, hey, this thing is not rendering properly, and so on. I do not like to deal with distributed systems anymore. I used to. I built my career on Erlang and Elixir, and then Haskell. So I wrote, real-time, near real-time distributed systems for a living. And those were the problems that I dealt with. And then I learned eventually, I hate this. I don't like having these problems. These are not the problems that I want to solve anymore. And I decided at that point, I'm just going to try having other problems. Like, why is this not rendering? Why am I getting, why am I getting 200 FPS when I should be having more? And stuff like this, right? Those were the problems I decided I want to have. So I then reoriented towards saying, I'm just going to try to do that stuff instead. Because I don't like distributed computing. I don't like how near undebuggable it is as soon as something happens, especially in the modern landscape where people are using microservices and so on. We should not have to make a thing or use a thing that concatenates distributed logs in order to figure something out. Like, fuck all of this shit. It's just, I could get into writing distributed, like writing networked services. I could get into it if maybe we could settle more on saying, hey, sometimes there's a program running on a computer. That's the thing. That's what we're doing. But I would say more often in modern times, it's we have 15 plus programs running on different computers. Sometimes they're on the same computer, but that's transparent to you. Kubernetes might actually put them on a different computer, so fuck you. And we're just going to make everything a distributed computing problem. Even things like a function call, right? I don't want those problems. And yeah, I would definitely build backends for people now. If we could just say, let's be sensible about this, right? There's a program running on a computer. That's really it. GG Rick. I don't know how to code and I want to make a slop product so I can pay for it. What's your product idea? Well, it's let's see. Uber for dog walkers. There you go. That's your slop idea. Just go implement it. It'll be fine. That's the one. Uber for dog walkers. Yeah. I mean, that's kind of what we're talking about, Beb. Actually, I did work on a backend that I thought this is reasonably, it's an interesting design, architecture, but it's not like too bad. That was when I worked at a company called Creative Assembly. It's a game studio. And this was the architecture was essentially, we were running Erlang nodes, right? So Erlang nodes, for those who might not know, they can talk to each other. So you can actually spread out threads on different nodes. And this is actually transparent to you. It's actually, transparent. You can have a process ID, effectively a thread ID that points to a different node, but you don't really need to care about that. And so what that architecture actually was we had these islands of meshed nodes, because one of the problems with Erlang back in the day, nowadays is probably less of a problem because they've made different algorithms for this. Every node network used to be a mesh network. This means that every node that you connect to the network actually has a connection to every other node in the network. So it grows exponentially, very fast. And all of these nodes are going to be pinging each other constantly in order to figure out if there's some kind of partition in the network, right? So what you end up with is, if you have enough Erlang nodes, they will basically just be pinging each other constantly. And you end up almost with congestion based on only the heartbeats that are going across all the time, right? So if we have enough nodes, let's say we had like 100 nodes, because all nodes connect to all other nodes, like one node will connect to 99 other nodes and so on. They'll all be pinging each other constantly. And it's a mess, right? So what this architecture actually did was, instead it said, for every service type, we're going to have an island of nodes that can be scaled. So it would start at 1, and then it would successively scale up if that node became overloaded, right? This meant effectively that we could scale each island, each service type up to, something like 5, 10 or whatever. But they wouldn't get overloaded because of this mesh network business. From each service, they would then speak, unfortunately, in HTTP, right, with each other, which was a massive problem. Like, that is definitely the wrong decision. What you would want to do instead is just have a persistent TCP connection. That's it. Between these services, there should have been essentially WebSocket connections or whatever. WebSockets are just TCP with extra steps, right? So you should have just essentially set up TCP connections between these different services. They can then talk really, really, really quickly and efficiently with each other instead of speaking HTTP, which is really slow, really not a good transport protocol for services that should talk to each other. It should have just been a binary protocol. But yeah, it was a good enough design, I would say. In terms of if you want to do microservices, all of that stuff, this was not really microservices, it was services. But we had these islands that could be sort of scaled up. It was pretty sensible. But yeah, most things are not. They're not thought out like this. People just sort of assume, oh, we're doing microservices. We're going to have like 150 of them, whatever. Yeah, no. This whole, everything is a microservice, actual microservice, like nano service. It does like 2 things or whatever, and it has its own little data store and all that stuff. It's a recipe for being a real fucking upset, is what I would say. Oh yeah, it's 100% over-engineered. A program that runs on a computer is the best way to start with any problem. Just one program running on a computer. It can have different systems, right? It's fine. One program can definitely have different systems. They can be all kinds of, you can architect it like, hey, this system doesn't know the internals of another system. That's fine. You can certainly do that very easily in almost anything. And yeah, that's where you should start with every problem. A program running on a computer, a single computer. And then when you've proven, hey, this is not going to scale, then you can consider, okay, what does that mean? Should we just add more of the same? Should we run on a better computer? Oftentimes the answer is run on a better computer, period. You don't need 5 really shitty ones to serve this use case, probably. You could just do one bigger one. In reality, you actually want 2 computers, but keeping the list of active public servers for multiple, well, I mean, it depends a little bit sort of what your... The most straightforward solution here actually is a database. But you can approach that in a lot of different ways. If you have a very simple, straightforward matchmaking server that needs to be talked to, write it in the simplest possible way, etc., then you could just use SQLite. And then you can still get you can have a solid database solution that allows you to query very efficiently from your set of things, because this is a query issue in the long run, right? You have these filters that are applied, etc., right? People have different multiplayer settings and so on. And yeah, you could just do almost any database solution will work there, but SQLite is going to be the fastest one for sure. If you run Postgres locally, you're going to be paying for just talking to Postgres, even if you run it locally. There's a cost. SQLite is a lot faster. So if you have a simple enough use case, you don't have multiple nodes that need to synchronize, blah, 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 all of that stuff, SQLite is the simplest, straightforward solution to this problem, because you get good queries. You get the speed of running just code locally, etc. And it can be file-based still. SQLite is actually not much slower when you use a file-based solution over an in-memory database. So yeah. But yeah, the problem of, hey, I want to get some servers and so on is, the problem there is actually kind of stale data more than anything else. I would favor, this is tricky, because you can't have, like, if you have too many game servers, you have too many incoming connections, right? I think that this one is defensible to do with HTTP. Just like the game servers can periodically send their status to the main server. instead of having a TCP connection open in this particular case? It depends. It depends a little bit on like how often are we doing it, what's the payload, and so on. You could also do a clustered solution, but this is a little bit over-engineered, where you have sort of, if you think about it like lieutenants, right? So you have the main, and then you have essentially a tree of servers that other servers report to. Those tree nodes can have persistent connections to the master server, right? And they can then send that data. They can have those connections open because they're very limited and so on. The leaf nodes, the servers in this case, they could also have persistent connections to their their node, essentially, right? So they could report with a persistent connection to a server that also reports to the master server and so on. But, there's a risk here that we're over-engineering this. You have to just look at your use case and actually think about it from that perspective. But there's so many solutions, and it's so fun to think about stuff like this, to be completely honest. But, it's really just write the simplest thing that can work. And in the beginning, that will definitely just be like a straightforward, hey, I'm telling you, here's my status, and goodbye for now, right? If you want an interesting solution, you could actually just do a less costly one with UDP. Also, Aaron, thank you for showing up. It was nice having you. Have a nice day, you too. So if you do UDP, so one of the downsides of UDP over TCP, right? TCP has guaranteed delivery. It sequences automatically and so on and so forth, right? So we get data in order. And we always, we guarantee delivery and so on within limits. UDP doesn't have guarantees. So what you can do with UDP effectively, if you think about it, real-time information, UDP works often for when we don't really care if we missed data. It doesn't have guaranteed delivery. But if we use UDP, we can actually have a less costly cost. Effectively, it's less costly, right? To just send a datagram, which is what you send. You send a packet with UDP. That's it. It doesn't have any guarantees that it will be delivered. But for real-time context, you just send the next one. And that means that even if you missed the first one, you got the next one. Or maybe you got the first one, you didn't get the next one. Maybe you missed both. But the next second, there's going to be a datagram again. And you're probably going to get that one. So it's only under, if you have a real bad connection or whatever, then yes, this would be a problem, right? But odds are one of these is going to go through and the information is going to end up on the master server. This also works, for example, when you have, let's say you have a camera. You have a web camera or whatever, you want to transmit this stream. In principle, you don't really care that someone missed 2 frames earlier. They missed a frame. If they get the frame now, that really is the only thing that matters. If you could send a snapshot of what the frame is right now, it doesn't matter that they missed a frame before. Now, in terms of video decoding, it's actually a little bit more complicated because you often do like these diffs from snapshots and so on. But in principle, when you transfer data, if you have the kind of data where you always really care about the latest version more than anything, it can often be useful to use something like UDP, where you just say, I don't really give a shit if I missed 5 packets and I got 1. The important thing is I got 1. Sort of. And then you can add sequencing on top of that so that you ignore packets that came before the one that you received. So let's say you receive 1 and it has sequence number 2. And then you receive a packet that has sequence number 1. You ignore the number 1 because 2 comes later, because you only care about the newest data. That's what I'm trying to say. So that can be useful. UDP is a lot less involved than TCP. TCP has all of these guarantees, and you know, you don't always need those guarantees. So that's something to think about. But, you know, again, I'm saying all of this now because we're thinking about it. It's so interesting and so on. But, you know, the truth is you're probably better off just making the simplest version that can work immediately. And then thinking about, like, if you actually have problems with this, you would then go and say, hey, how can I redesign this so that it doesn't have problems? That's mainly the thing, basically, right? Otherwise, we're just engineering for the sake of doing things, right? And that's not really what we want to do. We want to solve the problem. But yeah, I'm gonna go. I have to make some food and stuff. I'm gonna stream tomorrow, and we're gonna take a look at what we can do with this program. And we're probably gonna take a look at outputting some serialization stuff based on types and so on. And yeah, thank you for coming, everyone who did. We didn't have all that many viewers, but it's fine. It's nice. It's nice to stream again, and hopefully I can do this more regularly. And yeah, I hope to see everyone again. Like I said, tomorrow I'll be back. I don't really know when. It's going to be sort of impromptu. But, you know, have a good one, and ciao.